So let me start off by introducing myself. My name is Brendan Freehart. I'm a data engineer at Selectus, which is a DC-based tech company that created the tool Magpie. Magpie is a data engineering platform that helps companies accelerate time to value and reduces the sort of typical headaches associated with modern data challenges by unifying the data engineering tool set. If you would like to learn more about Selectus, have a look at our website, check out our YouTube page. We encourage anyone to reach out if you'd like to see a demo. Yeah, if this is your first time, welcome to the DC Data Engineering Meetup. We started the DC Data Engineering Meetup to connect DC's community of data engineers, which shouldn't be a surprise by the name. Believe it or not, we are out here in DC, we exist. We meet every 1 to 2 months. It used to be in person in the before times. We had world-renowned tacos, but now we are virtual for the foreseeable future. If you would like to present at DC Data Engineering, please fill out the form, the presentation form, which is on our Meetup page. We are also always looking for feedback on how we can make the Meetup better. So there's a survey as well. Both of those are in the description on our main meetup.com page. We're actually going to do announcements before the presentation tonight, just to get us started. So if you are hiring or looking for a job, or you have another event that you'd like to plug, please click the raise hand button in the bottom of the screen, and I can temporarily unmute you. Anybody? Okay. Oh, hold on, Ryan. Hold on. Sorry, I see someone. Ryan, please go. I think that you're muted. Okay, everyone just hold on. This is the virtual troubleshooting. Umar?
Hello.
Like, hey, I put you out. Ryan, I think you might be not talking. Sorry, Umar. Yeah, go for it.
Yeah, so I guess your question was if you're hiring or looking for a job, is that right?
Yeah, sorry. So announcements is if your company's hiring or if you yourself are looking for a job,
right.
Now is the time you can kind of give your spiel about who you're hiring for or what you're looking for.
Oh, so great. I am looking for a job. I'm in the market. I'm an operations research analyst. That's what my master's degree is in, and looking to get onboarded here in the next 7 to 8 months, and excited to learn about what's out there.
Great. So we do have a chat. If you want to go ahead and drop your information in the chat, maybe tell folks where they can find you. That would be useful.
Great.
All right, thank you. All right, I think we're good. All right, I'm going to get us started here, and yeah, if you have anything else, you can go ahead and drop it in the Q&A. Okay, so tonight we're going to be hearing from Nguyen. Nom has worked as a data engineer as well as a data analyst, data architect, DBA, backend dev. Nom's experience as a data practitioner led him to found Nom Nom Data. If you, as I said, if you have questions during the presentation, you can add your questions. Hold on, let me move. There's Nom, and also you can see him. If you have questions during the presentation, you can add your question using the Q&A feature at the bottom of Zoom. You should see it in your screen. And we'll also have a brief Q&A at the end of the presentation. Nom, I'll let you have the latitude as to whether you want to answer things live But presenting virtually is hard. There's no audience, so give him a round of applause. Click the little clap symbol if you feel so inclined. And then I'm going to hopefully not encounter any more technical issues giving you the share screen.
Awesome.
Cool. I think you're good to go.
Great. One minor question. So I haven't done this before. I want to try to make this as interactive as possible. Can anybody hit the like clap buttons or raise hand buttons? Do I see any response or feedback from that at all? Or is that only for Brandon?
I'm looking in. I see people raising their hand.
Okay. All right.
So hold on, Nom. Let's try this one more time. So can you click into participants? Sorry to all the attendees. I'm giving Nom my best at a live Zoom tutorial. So if you click into attendees, you see everyone's hands kind of going, like little blue hands going up next to them.
Yep.
Okay.
Awesome. That's
all right,
what I was looking
I'm
for.
seeing. I'm hoping that'll be. It's tough being interactive. I appreciate you pointing that out.
Awesome. So as Brandon mentioned, I've been data analyst, DBA data architect, cloud data architect. And one of the interesting things that I've found throughout my 20 years almost now of experience has been, this Venn diagram of data plus business value needs plus developers is kind of like the intersection of where I feel like data engineers and data architectures drive the most value. And if you're too far onto like one side or the other, you have like the opportunity to be marginalized a little bit. Another funny quirk that I found is that the number or the size of teams of data engineers seems to always be super, super tiny relative to the size of the companies. And just to get kind of like a litmus test here, how many data engineers here are on teams of like 1 to 2, well, let's say 1 to 5 people? How many people are data engineers? Raise your hand. That'd be a good question too. Okay. So of the people who aren't data engineers, I guess how many people have, or in their organization, teams of like 5 to 10 data engineers? Okay. So I saw 2 to 3 hands raising up for 1 to 5. I saw 2 hands raise up for larger. Typically, I don't really see data engineering teams larger than 10 to 15 people in the scope of the companies that I've worked with. And ever since kind of like starting this company, I've probably worked with more than 10 companies across the board. And it's usually a pretty small team, but they're usually tasked with delivering data in, super reliable ways across lots of different types of business users, interacting with lots of different types of developers, front-end developers, back-end developers, and kind of thrown the gauntlet of different technologies that we don't always have full control over. So both from the front-end user side, whether it be like Tableau, Looker, or other visualization tools, or from the back-end side, whether we're having to pull information from like MySQL, NoSQL, MongoDB, CouchDB, Cassandra, whatever else you guys name it, we just kind of have to deal with it. And so throughout my career dealing with like all these different clients, this is kind of what led me to build an app-centric data architecture. I'm probably on my 3rd or 4th iteration of this now. And this presentation is kind of all about like the core components, how we feel like it helps, some of the pitfalls that we've had when we've built an app-centric architecture, and some of the benefits that we feel like have been super powerful for us.
Hey, Nom.
Yeah.
Sorry to keep throwing you loops here. I think that so I'm seeing on the left side of the screen, a little chopped up, and it looks like, I can't really describe it any other way. The sort of pixels are moved around. There you go. Okay, cool.
Did it fix itself?
It did, yes, it did.
Okay.
Ghost in the machine. Sorry to interrupt.
No worries. So one of the first things that I kind of get asked is why we kind of wanted to make things app-centric. And one of the first reasons is, as a data engineer, I've seen lots of companies kind of duplicate effort. How many data engineers, when they go do a data task, show of hands, feel like they're the first person to ever do that task? More than I expected, but you guys are geniuses. I want to say, for a lot of backend engineers, I'm typically not the first person to have ever interacted with Redshift, not the first person to pull data from MongoDB. And so I feel like innately, part of the things that we're doing is kind of things that have been reinvented a lot before. And so one of the challenges that kind of came up is like, if we're going to keep repeating these things, what are the possible ways that we could reduce it? And obviously one way is to kind of like put it up on GitHub, but another challenge there is like, how do you make it usable for people as well? And we kind of felt like producing apps is an easier way to share things so that other people can leverage code or functionality that is produced by data engineers or backend engineers. And we kind of focus on data engineering because I started out as a data engineer, but I feel like this architecture could be extended to, other types of functionality, backend functionality as well. The next reason was because throughout my career, I've always found that I've had to deal with a plethora of technologies always not within my control. And then especially when dealing with technologies that I especially dislike, I'm always looking for ways to not reinvent the wheel. And I've found that while there is some consolidation, I think a lot of people are interacting with AWS, a lot of people are interacting with BigQuery. There's also a lot of sprawl around a lot of like sources of informations and third-party APIs that are like not very good. And sometimes I really wish that those guys could either just get their act together or I could just leverage something else that somebody else has built. Another reason why apps were appealing for us is because they're very targeted. I think one of the problems that I've experienced building data frameworks in the past has been just a lot of sprawl or a lot of frameworks that try to take on too much by themselves. And so there becomes a little bit of a blurriness in terms of concerns that should be around functionality, how to test that effectively, how to make sure that that runs effectively versus, what is this component trying to do and how can I package that up and reuse it in various places. And the last piece where apps become super compelling for us is distribution. I think one of the challenges that I've faced is when I'm trying to deliver value to stakeholders, if they're not as technical, or even if they're technical, but they're software developers in other languages, it was always a challenge for me to give them functionality or functions or tools that they could use. Because early on in my career, I'd be like, oh yeah, hey, just go run this command line. And sometimes analysts would kind of look at me like, okay, thanks for the command line or thanks for the function, and then just never touch it. And so it was really challenging for me to try to get more people to use my code. And I don't know if anybody else has the same problem or have had similar experiences around that. But I think adoption and distributing, cool things that you build so that not only other engineers, but less technical or analysts, maybe people that don't have the ability to spin up programming environments on their local machines, can leverage and use your stuff effectively. And so the next piece that I'd like to talk about is kind of like, what is an app for us effectively? I think phones kind of revolutionized what phone or apps kind of revolutionized what phones can do. And I feel like apps on your phone are slightly different from like Shopify apps or Salesforce apps or things like that. But at a high level, an app is something that a user can configure. And for us, one of those things is kind of like if you have a function or something that you're exposing as a CLI, almost inevitably you are allowing some parameters that the end user, whether it's a developer or someone else, can input in there to do something and get it to run something. And if it's in the form of a CLI, they can run that 5 times, 100 times, pass it in whatever parameters. But that's kind of like a simplistic version of an app, right? So they can run multiple instances, they can configure it. It's fairly self-contained. This is another part, and I think Docker has made this so much easier than it was before. If you look at the architectures for iOS apps or Android apps, like the amount of work that they had to do to kind of build the app SDKs and the app ecosystems around that, they put in a lot of work. But now it's so much easier to kind of produce apps that are fairly self-contained and can be reusable, that it made it easy enough for a team as small as ours to kind of build an app-centric data architecture. And then the last piece was that the apps needed to be easy to build. And so, I think Airflow is kind of a similar model to what we're doing. The difference is they have DAG tasks. Show of hands, how many people here are familiar with Airflow? Yeah, lots. Okay, that's what I was expecting. And so, I think one of the challenges with some of the Airflow installations that I've worked with was that, given the models and the templates, it was fairly easy to build, but that not all of the users that I wanted to have the freedom and capability to run the DAG tasks or configure the DAG tasks had the ability to do that, because it was highly code centric, right? Unless you are deploying updates to your Airflow, you're not making changes to your DAGs, and that's kind of by design. And that I would say is kind of more for a heavily programmatic data engineering audience. If your data engineering team is only interacting with other, Python-centric data engineers, then that's great. In a lot of the scenarios that I've worked with, there's just tons of analysts that are asking for self-service tools and help. And this kind of architecture kind of enabled that a little bit easier than us trying to configure Airflow to do that for us. And so what this kind of looks like in terms of an app is, let me share one quick thing here. Can you guys see the screen? Show of hands. PyCharm terminal. All right. So similar to Airflow, we feel like there has to be a fairly easy way to develop an app. And for us, an app is kind of synonymous with a function. What we're doing is producing a function. We're decorating it with the parameters, and it's kind of funny because the decoration here around, the inputs that you need. So this is a hello world. I'm going to say hello world X number of times. And if you give me a name, I'm going to say hello, DC data engineering instead of hello world. And so I decorate it with the parameters that I need. I give it an action, and then I kind of define a name for my app. And then when I deploy it, what it looks like in the platform is something like this. So here's a hello world example. the UI automatically gets generated based on the inputs. So, we felt like a UI was really important, but also that I would say a lot of backend engineers, there's this joke where it's a picture of a unicorn designed by a front-end engineer, and it's basically a bunch of sticks. And I feel like that's what it is like when I'm building UIs. And so I would say a lot of backend engineers aren't great or don't have the time to build amazing UIs. And that is a super valuable piece that is worth building if you can do it. But if you can't, having a framework like Airflow to get a UI for you, or having something like a platform like this to automatically build a UI for you makes certain things a lot easier. And so in this case, DC data engineering, UI, end user configurable engineering. I was also advised against doing live demos, but live logging, user configurable tasks, and this is a very simple hello world example of how someone might be interacting with an app. And in this case, similar to apps, you can subscribe to different apps. This is kind of designed so that data engineers or backend engineers can just build apps for all the things that they do and then share it and distribute it throughout their entire organization. That's one of the main goals for what we're doing. And so what does it take to kind of build an app, apptastic architecture? One of the core components is a really solid foundational platform. The UI that you saw, I think, is kind of that thing. Apple, they have their iOS platform. Google has the Android platform. Like without those things, those app ecosystems wouldn't exist. And so for us, building a platform that's super solid, pretty cutting edge technology, it also for us needed to be installable locally. We feel like data is something that I think is sacred to a lot of companies, and there's a lot of companies that we talk to where it's like, we love data, but we really have to own the bulk of data flow, and data can't really leave our network without our knowledge. So we kind of shy away from a lot of like SaaS data services for those reasons. And so all of those things are important to us. And so in the process of building this platform, we kind of ended up with a few technologies. One is React.js for the UI. So we went through several iterations on UI. React worked out really well for us. We have Flask for the API component backend. I think as a data engineer, if you're also working with Airflow, Flask may be pretty familiar. It's pretty simple. It was lightweight. I think those are a lot of the main reasons that we went with Flask early on. We also have MySQL database for the backend. I've heard a lot of people say, we need to be database backend agnostic, but I think at the time when we were doing this, the JSON support for MySQL was kind of a lot better than what we saw in Postgres. I think those were our two main options. I think Postgres is come a long way since, Oracle, damn you, Oracle. Redis, we have Redis for kind of like our queuing mechanisms on the back end. We use Loki for all the real-time logging that you saw. We have MinIO for backend storage, and we have Traefik for all of our networking. And what this kind of culminates into is a platform that allows zero downtime upgrades between running apps or instances of apps. You can get upgraded apps, and you don't have to take down your whole platform. One example of an app may be like web scrapers, which are, I think, notorious for breaking, usually because, Target, Amazon, or whoever changes their website, web scraper breaks. Whoever built that app can just redeploy the updated version of the app, and whether it's 5 people 100 people, a million people, like it'll just get the latest version and then run successfully on the next run. And so those are the main components that kind of exist today in the platform. And now we kind of talk about like the necessary features of the platform. And initially, I think we evolved kind of like Airflow, where it was just orchestration and a UI. So UI, first and foremost, it took me a long time to really get behind this. And it's really funny because I think back in the 70s, like when I went to college, they kind of like taught everybody about like the rise of Microsoft, and it was a whole bunch of people kind of doing back-end coding. Everything was command line driven, and the guys at Microsoft and I think Xerox at the time were like working on this new UI thing, and everybody's like, oh, let's get back to real programming. And then the UI is just like took over because so many more people could do things. And I didn't really think it was so much the case because so much of my work had been with command lines and code and scripts and all this other stuff. But probably about 4 years ago, I had a conversation with a product manager, and someone had built this really, really bad UI that everybody was using in the company. It wasn't related to data per se, but I was like, why is everybody using that? And then she was like, because it has a UI. And so I was like, okay, I get it. It's more important. I'm a little bit hard-headed, but it took me a while. Security and permissions, I think, is a necessity that kind of evolves over time. I've seen a lot of people kind of start with things like Airflow or more open source things, and then move towards paid services because security and permissions is just really hard to implement and has a lot of challenges. I think one of the reasons why not every company can afford to build out security and permissions in their own custom applications because it's kind of a pain to do. Deployment testing and testing frameworks. I think this is starting to become more regular, but I think it is still not as easy as it could be. I've worked with a lot of companies that have challenges kind of marrying the DevOps along with the deployment testing, or marrying the syncing of test data along with the testing frameworks. And all of that is made a lot easier if you're following some sort of paradigm like what Airflow has, or have an SDK or models that are kind of like I think we're using PyTest for all of our stuff, and it's been hugely beneficial. And then I think because we're so centric around Docker, the more you can get centric around Docker, the easier the deployment and the testing frameworks become. And then the last piece, I guess, is orchestration. I think you can start off, or a lot of data engineering shops that I see start off with cron and may still be using cron in a lot of places, but eventually you kind of got to like level up from that and get something a little bit more robust. Oh yeah, last bits, logging, scaling, routing, version control, configurations, all these things that I'm like, they don't add business value right now, but it's causing me so much headache and pain that I'm just going to spend a week or 2 weeks cleaning this stuff up. I don't know if any of the data engineers here have ever experienced the same thing. Raise a hand if you've just had to kind of like pause feature production to deal with, this kind of tech debt, unfortunately. Yeah, exactly. Next thing that we had to kind of consider was like when we were building the UI, how nice does it need to be? And if it was really just for data engineers, I'd be like Airflow's UI has gotten a lot better over time. It's probably taken like almost a decade to kind of get to where it is, like at least 5+ years. But for us, I think we were like, well, if we were going to have analysts and product people or marketing analysts or end users using the UI, it's got to be simple, clean, and easy to use. And so this meant that we had to really lock down like the service contracts between what the apps are doing, how they get their information and configurations for how to run, how they do their logging, how they maintain and manage secrets, stuff like that. And limitations around what the UI can and cannot do. And so I think some other types of app services kind of push all the UI stuff onto the app developers. This is why building a great Android app or a great Apple app, it's probably teams of like 20 developers, half of which are building UIs for games or whatever. But we kind of felt like for data engineering, it was okay to start with a little bit simpler of a contract, a little more limitations, but really amp up exposing like additional functionality that people are building. User experience was super important for us, making sure that it wasn't overly complicated. And we wanted to kind of make sure that if there were like super complicated things, it could be certain apps that are complicated, but we didn't want the flow of getting to those apps and executing those apps and running those apps to be complicated. The next thing is around config. Anybody here running Kubernetes as their backend for their data infrastructure? Handful, 1, 2, maybe 3. I saw another hand possibly pop up. I think Terraform, Kubernetes, a lot of that is kind of like pushing configuration as code. And one of the things that I'm finding, especially in the data realm, is there's so much stuff that applies and fits into configuration. Very simple example of this is we had a team of 50 analysts at one point, and they were all producing data sets and feeding them into our S3 data lake. And for a while there, they were just copying and pasting S3 paths, like putting in the wrong paths, putting in the wrong prefixes, and you're like, it's just a path. But because it's so freeform and hand entered, there were inevitably mistakes that would just cause problems. And so those are like probably simple versions, like paths. Your team is using this prefix for where it dumps data, is kind of like a very simple thing, but putting it into some sort of shared configuration is super valuable. I think a lot of the experiences I had with Helm and Kubernetes kind of made me hate YAML. And so we really wanted to make that part easy. Shared fields is kind of a slight extension of shared configurations. I would say shared configurations more resembles like a file format configuration. I've seen a lot of companies say, hey, you know what, any kind of like extract or export, we're just gonna standardize on Parquet. So everything comes out Parquet. This is how it's configured. Um, I've seen a lot of companies say we're gonna do it CSVs, and we're gonna delimit things with this. This is our escape character, and those are things that like if you just had a place where you could easily go to get that and everything could use it, that would be super valuable. Shared fields probably are more around the path type things. It's like a string or a single value that can be shared across teams. The last thing is connections and secrets, and I think that is a big deal. Unfortunately, I feel like people still reinvent the wheel and a lot of this stuff. I think Airflow had a pretty great model initially, but one of the challenges that we're seeing is every single platform now has a different way to manage secrets. And the goal, I think, for a lot of people is to maintain secrets in the highest tier level of platform and possibly trickle trickle them down. And so one of the companies that I worked with, they initially had all of their secrets and connections inside of Airflow, and then they kind of went to Amazon managing everything and started managing secrets using Secrets Manager. The quirky thing was the cost of managing secrets and secrets managers is kind of high. I was kind of shocked when I saw the numbers for that. And then the other quirk was that it actually made a ton more work for the team because they're just busy syncing secrets everywhere for all the different things that they were trying to do. So, trying to maintain a sane way to manage this, I think, is super valuable. The other thing that we had to go through was figuring out how to deal with testing and SDK frameworks for our testing. And so when dealing with apps, it really makes it a lot clearer how you can narrowly scope your functions and tests, because you don't really even have access to everything else. I think one of the challenges that I saw with Airflow is that there's a lot of tests that do integrations of like entire pipelines, and they were just like super crazy difficult to validate, and there's just like more work, I would say double or triple the work spent on the tests than actually writing the functionality. When you're testing in the scope of apps, you're actually not really able to do that. That kind of testing kind of has to fall into another place. And so it makes the scopes of what you're testing a little bit smaller. And then it also makes the integration with CI/CD pipelines a little bit smaller. And so the way that we break this down is that any kind of apps that get built and tested if there's any changes in the subfolder specifically for that app. And then any kind of like shared or integration type testing, we typically have like a commons repository where that broader spectrum of functionality gets tested. And it's worked out really, really well for us. So when we built the SDK, and especially when you're trying to like go down this app architecture route, you kind of have to have an SDK. If your apps aren't consistent, then it makes it really challenging to have those service contracts with the platform. And so we kind of centered on Python as a first language. We felt like it was the most robust, had the broadest user base for all of those kind of reasons. And it's worked out really well. It might be making it a little bit harder for us to tackle our second or third language for our SDK for the platform, but I think that we're very happy with the first choice. The next thing that is still kind of becoming an issue are the types of package functions. And so once you start letting people build the apps, I think the easy types of functions to have in an SDK are like, give me an app template, run my app, test my app, deploy my app. Those kinds of things are pretty standard. Then you have things that you have to publish out, like how do I do logging? How do I get my secrets? How do I update, parameters on my task? How do I send results somewhere, or how do I, track the results of XYZ execution? All of those things are kind of like first tier functions that need to be exposed when you're kind of dealing with SDK or designing things for apps. And then later on, as we start building like more and more apps across broader user bases, we're starting to find certain functionality, and this is where Airflow has operators or certain paradigms. The default for Airflow is like blocking or processing with date bounded ranges. Things kind of like that start to come into play when you have a lot of apps in the same space that should follow, I wouldn't say necessarily the same paradigm, but like certain families of apps kind of behave similarly. And so you end up kind of wondering if you need to build package functionality for those things to keep those kinds of things consistent. So if you have a suite of apps around Google Cloud, like they would have some similarly packaged functions that might become exposed as part of the SDK. And we're kind of running up against that now a little bit. And then the other piece is the CLI. And so this is a little bit ancillary to like the building of the apps. I think since we are still focused on delivering highly technical things, there's a lot of data engineers kind of working with us and building out functionality. Having a CLI where you can programmatically update tasks, kind of create projects, create credentials, things like that. And at some level, it's almost like we're becoming a platform like this becomes a mini Amazon where you're still producing code, you're producing your packages, and you're letting users on the other side kind of run your stuff. But a lot of the data engineers are fully interacting via code. And then the users, the analysts, the people that are getting value from the apps can still have the ability to leverage the UI, if that makes sense. And so along the way, this was probably like multi-years for us to kind of like build an app like architecture like this. I would say the value added and the number of people that we can like expose this to has kind of grown. And one of the interesting aspects, that I'll kind of reiterate from the beginning is a lot of the code that I built throughout my career, I would say early on, handfuls of people would use. Now the things that I'm building are being used by tens to hundreds to thousands of people. And I used to think that was something only reserved for front end engineers. And what it's becoming is that my knowledge, my code, the apps that I'm producing are really valuable and leverageable across a much broader spectrum of audience than I originally thought. And so maybe, I'm not great at building websites, but that doesn't mean all the things that I've built are not valuable. And it's also why a lot of these companies are willing to hire, fairly expensive data engineers to do all this stuff custom. And what I'm finding is that, a lot of this stuff isn't so custom. Maybe the DAG as in its entirety might be custom, like you might be doing one step before another step, but the overall pieces and components, especially if you kind of build them in an app-centric architecture, are not as custom and can be a lot more reusable across broader audiences than one might think. And so challenges along the way, one is, man, there's just like so much more stuff that a platform has to do in order to scale effectively. And so originally we started with, I think, a single Docker container that was the totality of the platform, and it ran other Docker containers as other apps. I think as you saw on the platform slide earlier, there were 7 different services, and we're like really trying hard not to add more. So that was interesting. The other thing that we tried early on was we went super thin on the UI stuff. It wasn't until I was maybe a year and a half into this where I just gave up and decided to hire a full-on UI person. My original UI was like functional, but not very nice. It was with Flask and Vue.js kind of interacting with the APIs, and that was just a lot more effort and a lot more difficult for me to maintain and manage. So we ended up ripping out Vue.js for React. And then the last one was Elasticsearch. So at the very, very beginning, like probably for the first couple months, I didn't even have like a logging infrastructure for the platform and just like log to files. Then we eventually went to Elasticsearch for logging, and we've been on Loki for over a year now. The scale at which, especially when you're not controlling it, the scale at which like logging happens for data is kind of massive. Like there's times when somebody was like processing and scanning files on S3, and for whatever reason, like they just decided to log every single file that they scan every single time they scanned it, and it was like logging millions of rows, every day, because it was like, oh yeah, I processed this file, and Elasticsearch was like such a memory hog, it just like caused things to bomb. It was a beast, so we had to get rid of it. Loki handles everything much better, and like one of the reasons why we kind of containerize or went with so many different containers as part of our app architecture is that similar to how Airflow has like their database kind of separate or independent. All of our services can be like cloud hosted or self-hosted for scale, but we also wanted to make sure that it was packaged small enough so that you could run it on your laptop. So that's it, everybody. Any questions?
Woohoo!
Sorry about that. Yeah.
No, I have to provide some of the interaction with it being virtual. Okay, so so I sort of tried folks in the chat to throw in questions. So they're coming in the Q&A, and I suppose I can read them live to you. And also, if you want to raise your hand, I could, I guess, let you talk. David has been pretty active in the chat. There's a few questions. First, he didn't put this in the Q&A feature, but he did ask about, as opposed to Airflow, using, what is this product called? Prefect, and if anyone has used that as a scheduler. None.
I have not used Prefect as a scheduler before, so I've tangentially heard of it.
We can do this lightning round then. Sorry.
Yeah, go for it. Go for it.
Yeah. So he says, if I understood correctly, an app is like a task in Airflow. How does debugging in an app work with the way that you laid out what sort of what apps are?
So I think that the apps, or the line between what the developer controls and what the user controls is starting to get a little blurrier. And so the developers kind of control the debugging of apps with test cases and use cases that they define. And that's almost completely separate from what the user, well, not completely separate, but independent from what the user configures it as. And so as an app developer, like I kind of know if I'm building an app that is interacting or downloading data from, let's say, MongoDB to S3, I know what the typical parameters are, and I'm giving the user some space to configure, the collections, maybe the S3 buckets, maybe S3 paths, maybe file formats. And as the app developer, it actually takes me a lot more time to kind of think about how someone might use it and all the different like flags that they would want, and exposing that in the UI. And so that's where the majority of the testing seems to happen, is like, how do I deal with these parameters coming in because I don't have any more control over it? And it kind of ties back to, as a data engineer, I always used to bitch at front-end engineers that didn't have like validation for like inputs that sent garbage into my database, and it's a little bit like that.
Good stuff. So Ka, I hope I'm not butchering that name. They asked, can you give a quick developer overview of your Nom Nom SDK in the chat? It's kind of a juicy question, but I'll
try to keep that short. So the platform that you saw, the Nom Nom Data platform, is meant to be a free platform that developers can publish or monetize apps that they build. And so the first use case is kind of like, let's say a data engineer wants to install Nom Nom Data inside their organization. They can publish and build private apps that they want throughout their organization, let users control and self-service, any kind of functionality that they build. But then they also have the ability to subscribe to apps that maybe third-party developers or someone else has built. And so the SDK is all around, what do you need to build an app? It's heavily Python-centric, and it manages how you get configurations, how you kind of like construct your UI, how you get help files to your users, and then how do you deploy to the container repository that basically, like, since an app is roughly a container, to the container repository that manages distribution of apps to, all the people that you're interested in distributing it to. Does that answer the question?
Can you raise a hand if it's limited functionality
Right, awesome.
here? I
Okay.
guess hand went up. I guess that's a yes.
Okay.
Yeah. Any more questions? I mean, I have one. What are you going to be for Halloween? Again, I guess the second one is what do you think the most apptastic appetizer is?
So since we're dealing with data, or at least the ones that I've dealt with are around data, I would say we've had a ton of traction for apps that enable SQL users to do more with SQL. And so I think a lot of SQL users are kind of like, they view themselves as scripters. Maybe they do a little bit of Python, and it's to templatize or make SQL more powerful. But the things that are definitely the most used are like things that allow users to control SQL statements, inject date ranges for them so they can process things in batch. There's also things that can send emails just directly from SQL statements. So it like queries a table. If something's true, it'll templatize an email from the contents of your query results and then send it off. And they usually, in the results, it's like email equals X, message equals X, whatever. But the same can be done for like sending messages to Slack, HipChat, stuff like that. I actually use that same mechanism. We have a stand-up that we always fight about, like who's going to go next, and I just like set up a SQL query to do a randomizer to send it to Slack every time, because we ran out of Slack apps on our free Slack, so I couldn't add any more apps. So I just added this one app that's like, okay, you can send whatever results that you want from SQL statement.
So I was that's funny. I was definitely making a joke about like a food appetizer, which I was going to say mozzarella sticks, but you came up with a wonderful answer. Actually, that was really interesting. So yeah, we're coming to the top of the hour, so I want to be sensitive to folks' times. Ka has one more question, and then I think we can, if one more question is all right with you, Nom.
Yeah.
Yeah. So I'll read it here. Does the SDK have specific support for Spark and Databricks Delta Lake, which I believe they're referring to Nom Nom Data as a SDK?
So I would say the SDK is not as prescriptive as like Airflow is around how things are done. To my knowledge, if you can write it in Python, then you can build it as an app. And so I feel like there's enough Python, libraries out there to interact or build an app to interact with Spark or Databricks, where you could easily build it on your own. But I don't think that, our goal is to build SDKs or wrappers around all of those things. It's more give people the ability to expose what they've already built as functions and turn them into apps that can then be exposed to their users, if that makes sense.
Yeah, it does. All right. Well, on behalf of everyone here and the DC Data Engineering Meetup, thank you so much for presenting tonight. That was really awesome. I know that the virtual thing is weird, but that was really interesting. So yeah, thank you so much. I'm gonna end the webinar now.
Sounds great. Thanks, everybody.
Bye, everyone.